Color management and color is a highly complex topic worth its own course. But to understand certain steps in the lighting pipeline, we will cover a few key concepts of color management. First of all, what it all boils down to: render engines and shader do not have a concept of what color space is. What this means is the algorithm of a renderer or shader will treat incoming color values equally and color values linear, regardless of which color space they are in. Practically, this means we need to make sure any textures fed to our render engine have a linear transfer function applied, and we are converting textures to a common color space. To understand these concepts, we'll take a small excursion into the history of color and the components of color space. In 1931, the CIE XYZ color space was defined, which encompasses all colors a human with average eyesight can see. It serves as a standard reference against which many other color spaces are defined, including the ones we will use. A color space is defined through 3 points on the XYZ CIE chart. The primaries which define RGB are the extreme vertices of a color space. All colors within these 3 vertices create the gamut, and these are all the achievable colors of the color space. The white point defines the points within the colors which are perceived as white or neutral. Your brain changes its perception of white depending on the viewing environment. Hence, we define several white points to compensate for this for a color space. Light is linear, but human eyes don't perceive luminance in a linear fashion. Our eyes are more sensitive in darker areas. An image encoded with linear values will look very unnatural to us. To compensate, we apply a transfer function to encode luminance in a non-linear fashion. We can apply this also to image formats. To save disk space, it is preferable to encode a transfer function into the image to favor tonal values our eyes actually see. Now back to our render graph. Since the algorithm of an engine will expect luminance to be linear, we want to apply the inverse of the transfer function before doing our calculations. Now we have to just make sure to define a common color space. This is where ACES comes into play. ACES, which stands for Academy Color Encoding System, attempts to standardize and simplify color management. It is a 4-step process. First, the IDT. The input transforms convert sources into the ACES color spaces. Several ACES color spaces exist, but we are only interested in ACES CG, which is optimized for VFX work. All our calculations we do should happen in this color space. Step 3 is applying a RRT, which is simplified said, applying an ACES look. The last step is applying an ODT, which will convert your image to the color space of a viewing device, for example your monitor. In our lighting pipeline, we will use OCIO to access the ACES color spaces. OCIO is an open source color management system developed by Sony Picture Imageworks. It is widely adapted by visual effects facilities and is well integrated with most applications like Nuke, Fusion, Maya, Katana, and so on. Even though the software we are going to use comes with OCIO and ACES bundled, we want to simplify our pipeline and install and set up a centralized OCIO config to make sure we're using the same OCIO config for each package. You can use the OCIO 1.2 config found in the color folder of the course download package. But if you prefer, you can also download the latest OCIO config package from the OCIO GitHub. We are only interested in the latest config setup, at this point OCIO 1.2. Select and extract the config to a location of your choice. Now we want to set up the environment variables to make the OCIO config available for all packages. I will show you how to set up the variables on Windows 10. Depending on your OS, this might differ though. Guides on how to set up environment variables for different systems can be easily found online, so I will just cover the one system right now. The variable names do not change depending on your OS, so please follow the same naming structure. To set your environment variable, right-click on the Start menu and select System. Search for Advanced System Settings and open up the setting. Now click on Environment Variables. Select New either under User or System Variables. type in OCIO all in capitals and add the path to the OCIO 1.2 config file in the variable's value. Hit OK. Let's hit New again. We want to reorder the active views so that our software packages point to Rec 709 by default. Active views defines all existing views in the OCIO config. You can find the full variable in the config.txt file living in the color folder. Now let's check and set up Katana and Nuke to make sure it's reading the config files correctly. The Katana OCIO setup is very straightforward. Go to the Monitor tab. If the environment configuration works, you will see ACCG and Rec 709 written at the bottom right corner. This means Katana assumes ACCG as the color space of the monitor frame buffer and will apply a Rec 709 output device transform to display the image on your monitor. Next up is Nuke. Open Nuke and hit S on the keyboard. This will open up the project settings. Switch to the Color tab and you should see the OCIO config grayed out. This means Nuke is reading the environment variable. We also want to have OCIO manage our colors, so switch color management to OCIO in Nuke if it isn't set.